Hello students, welcome to my channel Engineering Education. Please subscribe my channel. Thank you.
In this video we are going to discuss the solution of problem 13.2, chapter number 13, reciprocating internal combustion engines, from the book Applied Thermodynamics by T.D. Stapp and McConkie. The statement of the problem is: a two-cylinder 4-stroke gas engine has a bore of 380 mm and a stroke of 585 mm. At 240 revolution per minute, the torque developed is 11.86 kN/meter. Calculate the brake power, the mean piston speed in meter per second, and the mean effective pressure, brake mean effective pressure. So these three things are required in this problem. First of all, we will extract the information given in this statement, and those are: first, it is given that this engine has two cylinders, small n is 2, and is 4-stroke gas engine with bore represented with small d 380 mm. So it becomes 0.38 meter. Further, radius is required in calculation, so this value is converted to radius, which is 0.19 meter. Stroke length is given 585 mm, which is 0.585 meter. The engine speed is given, represented with capital N, 240 revolution per minute. It will be converted to revolution per second, because later on it will be used this value in calculation. So it becomes 4 rpm, revolution per second, 4 revolution per second, rps. Further, torque is given, which is 11.86 kN/meter. So it is converted to Newton meter, 11.86 into 10⁻³ Newton-meter. K is replaced with 10⁻³. These three quantities are required. First is the brake power, second is the mean piston speed represented with small v, and third is the mean effective pressure or brake mean effective pressure. B stands for brake and MEP in subscript stands for mean effective pressure. So coming to the solution of this problem, we have this expression for brake power, that brake power is equal to 2 pi nt, where n is the engine speed in revolution per second over here, and t is the torque given. So when we put the values, it becomes 2 pi into 4 into 11.86 into 10⁻³. So in kilowatt, the value comes out 298.1 kilowatt. So this is the required brake power for this engine. Further, to find the mean piston speed, for that we have another expression for brake power, that is brake power is equal to F into d by t, where d is the distance, and if we replace d by t with v, which is the velocity, velocity is the displacement per unit time, so brake power is equal to F dot v, where F is the force and v is the velocity. Further, we have expression for torque, which is 4 T is equal to force into moment arm, and this is basically the radius. So rearranging it for F F becomes equal to T by R, where T is the torque and R is the radius. So when we put F over here in this expression, the brake power expression becomes BP is equal to T by R. F is replaced with T by R into P. So rearranging this expression for mean piston speed, so V is equal to BP into R by T. So now BP is 298.1 kilowatt into R is 0.19 meter and T is 11.86 in kilowatt. So kilowatt and kilowatt will be cancelled with each other, and the value of mean piston speed comes out 4.77 meter per second. Third, we have to find the brake mean effective pressure. For that, we have the expression brake mean effective pressure is equal to 4 pi T by AL into N. So putting the values, we know about these values, 4 pi into 11.86 into 10 to the power 3 divided by A. A is the area, cross-sectional area of the piston or cylinder. It becomes 5 by 4 D square. D is 0.38 square into L. L is 0.585, which is the stroke length, and N, number of cylinder, are 2. So when we simplify this, we get 74,518.58 for the numerator, and for denominator we get 0.0663. So dividing it, we get the value of brake mean effective pressure, which is 11.23 bar. So this is all about the solution of problem 13.2. If you like my videos, please subscribe my channel. Thank you.